For a successful electrofusion weld, the following tools and cleaning agents are needed. First, a non-oil-based cleaning agent, some white lintless paper towels, a good scraping tool, a deburrer, permanent markers, rounder clamps to take the ovality out of the pipe, a good measuring tape, a piece of pipe, an Electrofusion fitting sealed in a plastic bag, as well as the welding machine. Note: keep the fitting in its packaging for as long as possible before doing the fusion. It protects the fusion zone as well as the fitting, and this ensures there is no debris inside of the fitting. Step 1. The insertion depth of the fitting is measured, and that insertion depth is marked onto the pipe. Because the fitting welds both sides of the pipe, the total distance needs to be measured and then divided by 2 in order to obtain the center point and mark the center point, which is then marked onto the pipe. In this case, the total distance measured is 4 inches. Half of 4 inches is 2 inches. Therefore, the center of this fitting is 2 inches. The 2 inches are measured onto the piece of unprepared pipe. The complete circumference of the pipe is then measured, and finally, the complete fusion area is marked off. This is done to ensure that the fluorination layer is removed from the welding surface. Step 2. Scraping the pipe. Before the weld can be made, the fluorination layer is removed from the surface using a good quality scraping tool. When scraping, scrape from outside the fusion zone through to the end point of the pipe. The swaft, or shavings, that can be seen coming off is the total distance of that fusion zone. The difference between the fluorination layer, which is the barrier layer, and the pure polyethylene can clearly be seen at this point. Black markings can be seen, which were marked through the fusion zone. This clearly shows the areas where the fluorination layer has not been scraped off completely. It is for this reason that it is important to clearly mark through the fusion zone in order to ensure that the entire fluorination layer is removed. By following this procedure, there is no doubt that the entire fusion layer has been scraped correctly, and that the fusion zone is now pure polyethylene, which will bond with the polyethylene from the fitting. Step 3. After a straight edge is cut, sharp edges are normally found on the pipe end. These edges stick out and need to be removed. The swaft, or shavings, also need to be removed from the edge of the pipe. This is done using a hand scraper on the outside of the pipe. This also smoothens and removes all the rough edges of the pipe that will be in direct contact with the fusion wires of the fitting. Lastly, deburr the inside of the pipe. Step 4. The complete circumference of the pipe is marked to ensure good visibility of the mark when fittings are inserted onto the pipe. Before inserting the fittings onto the pipe ends, rounder clamps are attached to the pipe just behind the insertion mark of the pipe, that is on the side of the mark which is along the length of the pipe. This will allow the ovality of the pipe to be removed. Note: pipe coils by nature have ovality which must be removed. Rounder clamps are attached as close as possible to the mark so that the maximum amount of ovality is removed from the pipe end. The fitting should fit snugly onto the pipe without one side of the pipe having to be forced into it, while the other side is very loose, as this would or could create a potential leak. Step 5. The fittings need to be inspected in order to make sure that they are functional and can be used for welding. Take note of the coil. Ensure that none of the element wires have been damaged. The pins. Make sure that they are intact and not damaged. Look at the outside appearance of the fitting. Ensure that the fitting has no physical damage to it. If all those points are intact and the barcode is not damaged, a complete fusion with this fitting is possible. Again, try and keep the fitting in its protective packaging for as long as possible. Step 6. The fusion zones now need to be cleaned on both the pipe as well as the fitting in order to remove all of the remaining residue that might have been left behind from the scraping process as well as the manhandling of the pipe and the fitting. The reason why white lintless paper towels are recommended is that they do not contain chemicals or ink, which the acetone or alcohol would dissolve, leaving that residue on the fusion surface and thus creating a weak weld. Remove a towel from the box, pour some cleaning agent onto the towel, and wipe through the fusion zone. Remember to always discard that paper towel and use a new one for every zone to be cleaned. The reason for this is that any residue that may have been wiped off one surface could cross-contaminate another if the same towel is used. Lastly, remove the fitting from its packaging and clean through both fusion zones of the fitting. Step 7. The pipe can now be inserted into the fitting. Check that the pipe does not go farther than the insertion depth indicator on either side. Once the pipe has reached the insertion depth on both sides of the fitting, there is no doubt that the fitting is centered and there will be an even fusion zone on either side of the fitting. Step 8. Confirm that there is no tension between the pipe and the fitting. To do this, check that the fitting moves comfortably over the pipe, making certain that the space between the coupler and the fitting is no more than 2/100ths of an inch. If this gap is larger, there could be a bad weld due to too little pressure being built up between the surfaces of the pipe and the fitting in the welding zones. Also, verify that the insertion depth indicators are marked appropriately. For example, if the fitting slid all the way forward on a pipe, there would only be a small amount of pipe exposed to the fusion zone on the one side, which would create a weak weld. The same would happen on the other side if the fitting were to shift, causing a very small fusion zone on that side, also resulting in a weak weld. Check to make sure that the pipe inside the fitting is not under stress. For example, if the pipe were to be picked up, the two pieces of pipe would sag from the fitting, creating stress points on the top side of the fitting and the bottom side of the pipe. With such a situation, there is melt flow flowing into the fitting and out of the pipe because of the pressures created through the fusion zones. So, it is critical that all these points are carefully observed to achieve a successful weld. Step 9. Before connecting the leads of the Electrofusion machine, make sure that there is a clean power supply. In other words, if using a generator, check that the generator has a minimum capacity of 4.5 kilowatts and that it's calibrated at 110 volts. Also, ensure that no other electrical devices are connected to that generator, such as drilling machines, jackhammers, any power source, or anything that's going to use voltage or that is going to use any current exceeding the combined allowable output of the generator. The reason for this is that the Electrofusion machine uses the same amperage and voltage to do the fusion as the output of the generator. Once this has been checked, connect the fitting to the leads of the Electrofusion machine, scan the barcode, press start, and the fusion will take place. The poles of the Electrofusion machine are not polarity conscious. In other words, they can be connected either left-right or right-left. This principle also applies when scanning the barcode. The barcode can also be scanned from either the left or the right. First, switch the machine on. The machine does an internal calibration test, making sure that it has been serviced and that it can perform the weld. Next, connect the probes to the fitting. The machine will then do an internal test of the fitting's resistance, and the screen will post a message, Scan Barcode. Ensuring that the pipe and fitting are not under any stress, scan in the barcode. The machine will then compare the resistance it tested on the fitting to the information scanned in from the barcode. This will ensure that the fitting is not over or under welded and that it's the right fitting. Press the Start button. Once the Start button has been pressed, the machine will perform a final self-internal test, verifying that the fitting's resistance is the same resistance to that of the barcode. If those fall within the given parameters of the barcode information, the Electrofusion machine will begin to weld the fitting, counting down the seconds for the fusion time. That fusion time can be read from the barcode looking at the last 6 digits. The first 3 of those last 6 is the time in seconds that is needed to do this weld. Step 10. Once the fusion is complete, unplug the machine probes. Document the fitting with the initials of the operator, date, fusion number, as per machine. Finally, write down the time for the fitting, including the cool-down time. The reason for including the cooling down time on the fitting is that only after the time has expired may the pipe that has been welded or the fitting that has been welded be moved.